Hello, chemistry students. Mr. Ross here, going to help you out with a couple of examples of gas law problems. And hey, I'm actually doing problems 18A and 19A from your homework. So if you're watching this video, hey, you're getting a head start already. So, what do you need to know? You should have a calculator handy and access to these gas laws. Is a big idea. If you have that and some paper or something, you're ready to go. So, here we go. Problem 18A asks us to figure out what will the new volume be if you had a pressure of 350 torr, that's P1. I'll start writing this stuff down. So here it goes. It says our pressure in the beginning is equal to 350 torr. Torr is a measure of pressure, like atmospheres or kilopascals. There's a bunch of other ones, but good to keep track of your units. Okay, and the volume of this bunch of air is, in the beginning, equal to 200 milliliters. Not quite the size of a can of pop. All right. These ones right here say like in the beginning. It's right there. Well, they're going to undergo a change of some variety. And for this particular problem, for 18A, it says to have a brand new pressure of 700 torr. The pressure has gone up. All right. And they want us to figure out what happened to the volume. So they say the new volume V2. What's that? Okay. Well, look at that problem right there. They've given us three things. They want us to solve for V2. The first thing I hope you're doing is saying which of these awesome equations is the one that will help us figure it out. Which one has a P1 V1 and a P2 V2 to it? And I think I've just described Boyle's law. If we know three of the four variables, we can solve for the fourth. So hey, let's give that a go. All right. So it looks like P1 V1 is equal to P2 V2. And built right into Boyle's law is the assumption that nothing else changes. Not going to mess with the temperature, not going to mess with the amount of gas that's in the container. Like all that stays the same. So that's an important thing to keep in mind. It doesn't say that it changes. It's a pretty safe assumption that that's a constant. So we'll go with that. And let's plug in some numbers here. All right. So we give ourselves some room to write. And for P1, I have 350 torr. And for the first volume, I have 200 milliliters. That's all going to be equal to the new pressure of 700 torr times the mystery volume 2. What's over there? We plug the numbers in, and at this point in time, it's only math, and you can use your algebra skills to say, I want to solve for V2, and you get rid of this 700 torr. So, how do we get rid of a number like that? Let's divide both sides by 700 torr. Something divided by itself cancels right out. And hey, the units have to work out too. Torr divided by torr cancels. And here we go. 350 times 200 milliliters divided by 700. We're going to figure out what the new volume is. And before I do it, I can make an educated guess and say, hey, if you had a volume of gas that gave big, and you increase the pressure on it, we should be able to squish it. Higher pressure, lower volume. So let's see if that turns out to be right. 350 times 200, got it, divided by 700, and there we go. And the new volume is 100 milliliters. Hey, there we go, that makes sense. Look at that. Twice the pressure, half the volume. Sounds like an inversely proportional relationship to me, but hey, we got there. We showed all of our work. If you're doing your problems like that, you're going to have a successful time in gas laws. There we are, problem 18A. Let's do one more to seal the deal, and this one's going to be problem 19A. All right, let's get some room to work. Let's go blue. Celsius. Okay, so that's what we have there. And the first thing we're thinking of is which of these equations has two volumes and two temperatures. And if you're looking at it right now and thinking Charles's law, you've got it. The other one's is pressure, temperature. This one's everything. We'll get to use that one eventually. But yeah, Charles's law should work out. Okay, we're going to have V1 over T1 is equal to V2 over T2. And just like before, it doesn't mention pressure, it doesn't mention moles of gas, so we have to assume that the pressure and the amount of gas in there does not change. Those will remain constant. All right. There's one more twist to this one, and that's Kelvin. That's the temperature scale that scientists use for temperature, because if you guys know, or anybody that lives up north knows, the temperatures get to zero and they can go negative. And wow, what happens if the temperature is zero? You're dividing by zero. If you do that, your calculator will probably explode into a wild fireball and hurt people around you. So please never try to divide by zero. It's a bad thing to do. So scientists devised a new temperature scale that starts at absolute zero. Oh, it's a fun topic, but the main point is it can't go negative with Kelvin. So that's important for our chemistry calculations. So we'll use Kelvin. Besides degrees of Kelvin, it's the same as Celsius, but it starts at a much lower temperature. So the big idea here is if you're going to do these calculations, you want to convert your Celsius temperature into Kelvin. And all you have to do is add 273 to your Celsius temperature, and you'll end up with your Kelvin temperature. All right, let's do that first. If you don't, you'll get wildly wrong answers. 273 plus 27, that ends up being, 300. So we'll change that up. We're talking about 300 Kelvin now. And 273 plus 77, that ends up being 350 Kelvin. All right, that's really important. Now let's set up our equation. Okay, V1 is 80 milliliters. T1 is 300 Kelvin. Got it. We're solving for V2 right there, and the new temperature of 350 Kelvin. All right, and this is not too bad when it comes to algebra. We want to get V2 over here by itself, so let's multiply both sides by 350 Kelvin. So times 350K, and that's 350K over here. This divided by itself, bam, disappears into mathematical oblivion. Kelvin divided by Kelvin cancels, so we know our final volume will be in milliliters. But what's the number? 350 times 80 divided by 300. I need to do some math in my head. 100 and something? Let's see. 350 times 80 divided by 300. And wow, it's close. 93.3. And really only have two sig figs. So I'm going to say for a final answer, the volume is going to be 93 milliliters. And there you have it. The higher temperature, bigger volume. And anybody who's ever had a birthday in the wintertime knows if you have balloons, if you walk outside with the balloon, it's nice and inflated, and it gets to be super cold, well, it gets smaller. So higher temperature, bigger volume. If it was colder, it'd be a smaller volume. But you can calculate all of it with the gas laws. There you have it. Hope that was helpful, and have a fantastic rest of your day.